Okay, good afternoon again. We're on a new topic. As we're observing this shape, we can see that it's a polygon, a three-sided polygon, commonly known as our triangle. And when we're talking about triangle, we talk about sides and angles mainly. We're talking about triangles. With one observation that we can see that it is not a right angle triangle. You can label it an acute triangle, or we can draw another type. It's called an obtuse angle triangle. Okay, so we can define the properties of triangles based on angles, but this is not a right angle triangle, so it's important to observe that this polygon, this triangle, is not a right angle triangle. Okay, so the emphasis and focus on this lesson will be on acute angled or obtuse angle triangle. This topic cannot be used with right angle triangle. When we talk about right angle triangle, we talk about the Pythagoras theorem or the trig ratios to solve those problems. Okay, so we're still on trigonometry or different aspects. Now, to bring out some of the properties of this triangle. Okay, so the first thing is not a right angle triangle. Let's call it triangle A, B, C. See, I'm going to label it A, B, C. So the polygon starts having meaning now. Okay, so here are the vertex where we label A is called angle A. At this vertex where we have capital B, we can call it angle B. Here at this vertex where we have capital C, we can call it angle C. So angles are often named with capital letters and are found at the vertex of the polygons. Okay, now from the point of the vertex here to this point at B, we know that this is the side, and the side usually have length, whether it's given or you have to find it through calculations. So we can call this side AB or BA. So we can call this side BC. So we did this already just to recall some information which is important. Okay, so we can name sides with two capital letters, so we can call this side AB. Okay, so angles are named with one letters, which is called angle A. Now, importantly, because this side is in front of, is opposite to angle A, we can call this common A. So we can call this side capital with two letters BC, or if we are using common letters, we call it side A, common A, because it's opposite to capital A, which is the angle. Hence, if this angle here is C, then the side opposite to it we can call it common C. So we can name sides with two capital letters or one common letters. And if this angle here is B, then the side opposite to it is called common B. Now what this is saying that there is some relationship between the angle in a triangle and the side that's opposite to it. There's some relationship between the angle and the side that's opposite to it. Okay? Because if the angle was to, legs of the angle was to open wider, then the length of the side would have to open wider. If the legs of the side of the angle should come inside, then the length of the side will become smaller. So there's some relationship. Okay, so what we're going to learn about using this type of triangle, so we're not talking about right angle triangle, now we're talking about maybe acute angled or obtuse angle triangle. Okay, but we are going to learn how to find missing sides and missing angles. Okay, but most importantly, we don't use right angle triangle. So we see where right angle triangle comes in many different topics: elevation, depression, trig ratios, Pythagoras theorem, and basic bearings. But as we improve or we move further in the topic of bearings and it becomes more challenging, then we have to learn about other methods of solving triangles that you may create through bearings that cannot be solved using trig ratios or Pythagoras theorem. Okay, so this is something just to recall. Not a right angle triangle, and the sides and label. Okay, so the topic we're going to focus on today is called the law of sines and or sine rule. The law of sines, or commonly known to us as sine rule. Okay, so we're still on trigonometry, so it falls under trigonometry also. So the law of sines or sine rules. Now, as Behrens' question increase in difficulty, we have to learn about the law of sines and the law of cosine. But for this short video, we're just going to learn about the law of sines. Okay? So the law of sine or the sine rule on the trigonometry can be used to calculate unknown sides. So if we don't know the sides of a triangle or the angles in a triangle, which is not a right angle, that is key. So when you see a question and it's not a right angle triangle, they ask about sides and angles, these laws, whether sine rule or cosine, should come in to your thought process. Okay? Now, we are not going to prove the formula. We're just going to go and write the formula straight forward. But the law of sines says that the ratio of the side over the angle is equal, of one side is equal to the ratio of another side over its angle. So it's the side, common letter, over the angle, which is equal to side C over sin, which is sine C. So A over sine A equal B over sine B equals C over sine C. These three fractions, or these three ratios, are considered to be the sine rule. You will not be using all three fractions at the same time, but you might be using any two at any given time to solve a question about missing angles and sides that's not a right angle. Again, so this entire formula or equation is considered to be the law of sines or the sine rule, but you won't be using all three of them. It can be done, but you won't be using all three of them at any point. You will only need two to solve the missing angle and missing side. Okay? So it's the side over the sine of the angle. Sine rule. Okay, let's go into it. Alright, so it's used to find missing angles and sides. Let's look at different conditions under which we use it. Let's look at condition 1. Condition 1 says that when given the length of two sides of a triangle and an angle to find another angle. So you're given the length of two sides on the triangle and you're given one angle and you're asked to find another angle. So this is one time you can know when you're to use the sine rule. Okay, so here's an example. Given triangle ABC, using symbols, math language, with AC equal 13 meters, AB equal 19 meters, and angle C, another symbol here, another way of writing angle. So instead of writing the words, they can write like this. Angle C equal 55 degrees. Calculate angle B. So another notation here for how to write angle. So it can be written as this, it can be written as this. So we have to know our notations, whether it's multiple choice or paper 2. Okay, first thing, let's label a triangle. So it's called this, I'm labeling this way, capital A, B, and C. Most times, or sometimes, they'll draw the triangle for you. Sometimes you have to draw it your own self. So you have to understand what to label and put on a label. So let's say with AC, so it's capital AC, that means talking about the side, is 13 meters. AC, so we have 13 meters. And side, since capital letter side, AB is 19 meters. And angle C, so the angle at C is 55 degrees. Okay, so this is condition 1 because we are given two sides and an angle to find another angle. So they're asking us to find angle B. So we're given two sides to find an angle. Okay, so we're going to start off with what they asked us to find. So we say it's the side over the angle. So the formula would be, since we're asking to find b, the side opposite is called common b over sine b equal, so we're working with the side that's given, so common c over sine c. Now let's substitute. So it's the side, so it's 13 over sine b, because we don't know the angle, because the angle is down at the bottom of the formula, equal side, which is 19 common c, over sine of c. What is sine of c? So sine 55 degrees. So there's a relationship between this and this, so that's why we have it as a fraction, and there's a relationship between this and this, so we have it here as a fraction. Okay, so from here is basic algebra. Now observe, it's an equal sign between the ratios or the fractions, so it's not cancelling, it's cross product or cross multiply. Okay, so it's basic algebra, remember. So we want to find sine A, so we're going to cross multiply, or what we say called cross product. So sine B times 19, so it'll be 19 sine B equal 13 times sine 55. Okay, remember the aim is to find angle B. So therefore sine B equal 13 times sine 55 over 19. So here we have condition 2. Condition 2 says that when we are given two angles, so condition 1 talks about two sides and an angle. So when we do use the law of sines or the sine rule again, second time, when you see a question that gives us two angles and the length of one side to find another side, and it's not a right angle triangle, then we can use the sine rule. So we are given in triangle PQR, we are given two angles and one side to find another side. Okay, so remember that the ratio is side over angle. There's a relationship between this angle and this side, this angle and this side. Okay, so it's side over angle, or side over the sine of the angle. So let's call this side small q, so common q over sine of capital Q equal relationship between this and this, what is given, which is common R over the sine of the angle. Okay, so what is q side? We don't know, over the sine 77 because it's opposite. So there's a relationship between this. So a side over the angle equal side for r 43 meters over the sine of the angle, which is 68 degrees. So now we are going to cross product, cross multiply, not cancel. Remember, we're not canceling, we're cross multiply. So this multiply by this, and this numerator by this denominator. So I like to work with the term that we're trying to find. So q times sine 68 will give us q sine 68 equal to 43 times sine 76 will give us 43 times sine 77. Okay, so we can go ahead and transpose sine 68 from beside q. We're going to break it down until we find q. So 43 times sine 77 degrees over sine 68. Okay, and when you break down all of this, we can push all of it in the calculator. We can do it by parts. We can find the sine of 77 multiplied by 43, then we find the sine of 68, and then we divide, and then we'll get our final answer, which would be 45.18 meters, because we're trying to find the sides. Okay, so there are two conditions. Condition 1, two sides and an angle. Condition 2, when you're given two angles and a side to find the length of another, and it's not a right angle triangle, we use the law of sine or the sine rule.